for the purpose of revision. Last time we have talked about some features of the switches regarding if it's NBS series, and we have gone through some ES series configuration. We have talked about VLAN, port isolation, and some scenarios of VLANs. Why do we need the VLANs? And in the same time, what's the purpose of port isolation? We have talked about access control list, allow, deny queries. And today we will continue our switching session talking about DHCP. Well, DHCP is a dynamic host configuration protocol. Simply, it's a protocol which gives IP and some other parameters regarding the IP address to the end points. So for example, we have here one NBS switch. This is NBS switch acting as a DHCP server. Well, server means it's responsible for anyone on the network asking for IP configuration. It will go directly to the server and say, hello, I want IP address. I want the subnet mask. I want your default gateway. And why not giving me the domain name system, DNS? In the below scenario, you can see one of the MBS series is acting as DHCP server, and the other one is access switch, which is just passing the traffic from the server to the endpoint. So simply, the DHCP is the main purpose of the DHCP is obtaining IP address and the subnet mask and the default gateway to the end users, to the clients. Let me maximize the screen. Okay, and here how you do that configuration. You go for the layer 3 interfaces, and you can see here the network mode is static IP. This is for the switch itself. The IP address is 192.168.16.1 in this example, and the subnet mask is 255.255.255.0, and it's VLAN 16. So the users belongs to VLAN 16 will get IP address starting from 192.168.16.2, and the IP count is 100. What does it mean? It means that the beginning will be .2 and the end will be .102. The lease time is the time this IP address will be renewed, which is 1,800 minutes. You can adjust it according to your requirements. So let's talk about DHCP snooping. What is DHCP snooping? DHCP snooping is how you protect your network. So for example, if we have NBS switch here, this NBS switch, and those end users are connected to the NBS. So let's say this is user A, user B, user C, and this is DHCP server, which is responsible for serving the endpoints to give them IP addresses. All right. And let's say someone from our company or from that campus joined our network and installing some sort of softwares, and instead of asking the server to get IP address, he will redirect the traffic. So if user A wants an IP address, the traffic will go to the attacker or whatever, the bad user, and it will give IP address that will affect the network. So you have to enable the DHCP snooping on the DHCP scenarios. Okay, and we will check how you configure the DHCP snooping in such a situation. Well, as a gateway device for users on the Compass network, the core switch enables the DHCP function to meet the requirements of the users. You can have many DHCP server on that core switch. On that core switch, you can have DHCP server for VLAN X and VLAN Y, VLAN Z, and so on. Okay, so accessing the Compass network to obtain IP address, which is the main purpose of the DHCP server, automatically. At the same time, an illegal DHCP server is attached to an access switch, like you can see here. This is illegal DHCP server. It might be a user with a laptop or a computer installing some sort of software that giving IP address to the end user. So if someone from PC1 or PC2 is asking for IP address, this illegal DHCP server will give them IP address, which may affect the network. So the terminal sends out DHCP discover broadcast packet, which is received by the core switch. So at the beginning, you turn on your PC and you send asking for discovering DHCP server. It's like you saying, hello, anyone here can give me IP address, please? So this is discovering, okay, which is received by the core switch, which is the legal DHCP server. This is the legal DHCP server, and illegal DHCP server at the same time. So the broadcast will be sent to this switch, which is legal, and it will be sent to this illegal switch as well. And here is another discover. Both the core switch and the illegal DHCP server will respond with an offer. So PC1 is sending a broadcast to everyone attached to that switch. Even if there's some servers here, it will send as well a broadcast. Okay, so that server will respond, hello, I can offer you some IP address if you want. So this is offering. And that one as well will send an offer. Okay, so who should I trust as a PC here, as a human being here, working from his PC, asking for IP configuration, DNS, gateway, subnet mask, and so on? Who should I trust? The terminal, which is PC1, may first receive the offer message responded by the illegal. Okay. And then PC1 will send a request message to that illegal DHCP server to request an IP address. So that illegal offered him an IP address. And then when he offered him an IP address, he said, oh, please, I'm requesting IP address. Can you give me, please, IP address so I can go to the internet? So the illegal DHCP server respond with ACK, and that means acknowledgement. I'm acknowledgement that I have received your data and I'm ready to give you IP address, and provides incorrect IP address and DNS and gateway and other information. So the terminal terminal 1, which is PC1, cannot access the internet. Maybe behind that server, some illegal contents they will sneak your data. Maybe they will steal your data. So to cut it short, this illegal is sending an offer to PC1 and saying, hello, PC1, I can offer you IP address. I can offer you subnet mask. I can offer you gateway as well. So you can go to the internet. This is the internet. Okay. So how do you know if this is legal and this is illegal? This is came as DHCP snooping. Snooping is someone trying to spoof the packet sent from the PC to the server and the server to the PC back again. So the only solution is turning on DHCP snooping. It's a technology that can solve this problem. All right, so this is how the packet goes from the PC1 to the access server, and then it reaches those two DHCP, as we explained, the legal one and the illegal one. Why it's reaching? Because it's broadcast. And broadcast means it's sending to each port on that switch. It's broadcasted. And then this server is offering DHCP, hello PC1, I can offer you some IP address and DNS and gateway. You are welcome if you need. And he is starting the illegal server, starting to offer as well IP address, subnet mask, gateway. So who should I trust? This is a big problem, because if you trust that illegal DHCP server, you will go in something called black hole. Black hole. So PC1 doesn't know who is legal and who is illegal. PC1 doesn't know. So PC1 is requesting from illegal server, and the illegal server is sending acknowledgement, which means I will give you IP address, subnet mask, and gateway. So you have to turn on, and we do recommend in many scenarios, this is a must. If you have a DHCP server on the core switch giving IP address to the end user, you have to turn on the DHCP snooping. So from the security tab, you click on DHCP snooping and you just turn it on. Okay. All right. So are you sure you want to enable DHCP snooping? Yes. Okay. I want to enable the DHCP snooping. So in the same time, you have to decide which port is trusted and which port is untrusted. What does it mean? It means that if this is our switch, if this is our switch, hold on please. If this is our switch and we have here the legal DHCP server, and we have here the illegal DHCP server. So this is legal and this is illegal. So simply you are telling the switch, please, if someone at the back end, which is might be PC, by the way, it might be IP telephony as well, requesting IP address. It might be CCTV as well, requesting an IP address. So you are telling the switch, I do trust that port to give you DHCP server. Please switch, don't trust any other port. So this will not be trusted. Maybe you have another here, illegal DHCP server, DHCP, and that one is illegal as well. So you are telling the switch, for the DHCP snooping, we already enabled it, and that's fine. But for extra security, we're gonna say, trust this port, because as an IT administrator, I know that gig 1/5 is our DHCP server, which is connected to gig 1/5. So we trust this port as legal DHCP server, and we don't trust that port, and we don't trust that port. So this is simply trusting the ports that is connected to your legal DHCP server. So you can enable the DHCP and select the trusted port. Let's say this is our trusted port, which is port 23, which is connected to our DHCP. Okay. As you can see here, for this example, port 6 is the trusted port for legal DHCP. And then you click save, and that's it. Okay. For the link aggregation, the link aggregation is aggregating multiple links connected between switches in order to have redundancy, and more speed and more throughput. So what is link aggregation? In the following scenario, in order to meet the data interaction between different servers on those two switches, the core switches must have higher bandwidth, and at the same time, redundant backup of the link is required. So if this is failed, this will work. Maybe it's not just two cables connected to that core switch, maybe more than two, maybe 4 cables connected between those two switches. So what is the purpose of aggregating those ports? The purpose is higher bandwidth and redundant backup. Usually, the number of physical links between core switches can be increased to improve the link bandwidth. Like we have mentioned here, not just 2 links, you can have 4 links, 6 links, 8 links even. So that improves the link bandwidth between core switches. When spanning tree protocol is enabled, and we will talk shortly about that spanning tree protocol, redundant links between cores will be blocked by spanning tree, because the purpose of a spanning tree, it's not sending the data and receiving it again, going in a redundant loop, which makes something called layer 2 loop. So how we avoid that? By enabling STP, which is spanning tree protocol, and we will talk about that shortly. So the redundant links between cores will be blocked by spanning tree. Although redundancy backup of links can be achieved, the purpose of improving link bandwidth cannot be achieved. So here, as you can see, we provide redundant links, but doesn't improve the overall bandwidth. Why? Because this port will be blocked thanks to spanning tree protocol, which avoids loop at layer 2 stage. So if this port is blocked, the traffic will goes on that port only, going in and going out. So we are not here achieving backup. We are not here achieving backup link. So link aggregation simply is a technology to combine multiple network connections in parallel in order to increase the throughput and provide redundancy in case one of the link fails. So if that fails, that will work. Maybe you have more than 2. You can aggregate up to 8, maybe. So if 4 fails, we have other 4. So you keep the connection up. This is the purpose of link aggregation. Okay. How you do the configuration? You click on boards, and then you can see here the aggregate boards. And thanks to the NBS, it shows you the maximum limitation of any feature on the switch. So up to 8 aggregate ports can be added. An aggregate ports contains up to 8 member ports. So here is our first switch, and here is our second switch. So you can aggregate up to 8 ports between those switches. So what's the purpose? Redundancy. And speed. Okay, but please note that there are some protocols between those two switches to understand each other. So if switch 1 is working on something called LASP, which is link aggregation control protocol, this one should agree to work on LASP as well. So NBS series doesn't support LASP. It supports something called static link aggregation. Okay, I can see someone here is asking a question. Okay, this is Kelvin. Thank you for showing the WhatsApp group. Okay, so simply you click on the ports and then the aggregate ports, and then you starting telling the switch which ports will be aggregated. Okay, as you can see here, we have aggregated port 1, port 3, port 4. And the good thing here, you can do some load balance on those ports. That load balance maybe depends on the source IP only, depends on the source MAC, source layer 4 port, which is transport layer, which is TCP or UDP ports, maybe on the source port, without mentioning the transport port, the destination MAC, the destination IP address, and the destination layer 4 port, and the source and destination MAC. You have a lot of load balancing here. You can choose according to your requirements. Okay, we have chosen here source and destination MAC. So we are load balancing those aggregated ports based on source and destination MAC addresses. So you choose here the load balance technique and the aggregate ports, how many ports you're gonna aggregate. And for your convenience, this is the symbols of aggregation ports. This is the symbol of uplinks. This is copper, this is fiber, this is unavailable, and the black one is available. As you can see here from this switch, this is the uplink, right? And those are available. No one use it. Okay. So we can aggregate here board 1, board 3, board 4, and then you click save. Okay, and you name that aggregation, as you can see from the screen. And we have mentioned the NBS 3100 can support up to 8 aggregate ports. Other NBS series switch can support 16 ports. 16 ports. You can aggregate up to 16 ports. But NBS 3100 is only supporting 8 aggregate ports. All right. So far regarding the DHCP and link aggregation. Is there any question we can share to each other? Please feel free if you have any question on those parts, the DHCP part or the link aggregation part. My colleague Kelvin will answer you If you have any question, you can simply post it on the chat. Okay. All right. Now we will talk about rate limits. What is rate limit? And what is the scenario of rate limit? The purpose of rate limit is to protect the system by limiting the rate of concurrent access request or request within a time window. Once the rate limit is reached, service can be denied or traffic shaping can be performed. As you can see here in this topology, we have the aggregation switch, we have the access switch, and we have limited the rate of that PC to 2 meg. So when that PC is sending traffic more than 2 meg, it will be denied. As you can see here, sorry. So the rate limiting simply is limiting the rate of devices connected to the switch. Okay, how you do the configuration? From the ports, you click on rate limiting and you start to do rate limiting to the ports you want to limit. You can as well do patch edit if you have many ports connected to endpoints. Those endpoints, maybe this is group A and this is group B. So maybe you want to limit group A to 2 meg as a rate, and maybe you want to limit group B to 5 meg as a limit. So you can patch edit all together in the same time to 2 meg and those two to 5 meg. That's the purpose of patching. Okay, as you can see here, the transmit and the receive rate, because it's two-way rates from the PC to the switch and from the switch to the PC. I do recommend both ways to be the same. So if you are doing here 2 meg, so the backup will be 2 meg as well. Okay, so you simply select the port you want to rate limit and start putting the number of kilobit per second. Please note it's in kilobit per second, and the maximum is the maximum port limitation, which is, you can see here, it's 1 gig, the maximum. Okay. We have limited gig Ethernet 21 to 2000 kilobit per second, which is 2 meg for RX, and for transmitting TX, we have limited to 2000 as well. Okay, right, any questions so far? Please feel free if you have any question. Anything is not clear, we can repeat it again. All right, the IGMB. What is the IGMB? The IGMB stands for Internet Group Messaging Protocol. So it's Internet group and they are messaging between each other. It's a layer 2 multicast application. It's a layer 2 multicast application protocols. With the continuous development of communication between devices, traditional data communication services can no longer meet people's need for information. Point to multi-point architecture services such as videos on demand, internet TV, and video conferencing have been widely used. We nowadays mostly use the video conferencing and maybe the voice conferencing. Maybe we can play some games online. Maybe we can play some games online. So to solve this point to multi-point communication, point to multi-points communication, it can be realized through unicast and multicast. Well, unicast is someone talking directly to someone. It's unicast. But for multicast, there's someone is talking to selected people. And those people are receiving that signal all at once. So this is multicast and this is unicast. What about broadcast? Broadcast is all to all. So broadcast means the message is broadcasted to all the people connected to each other. But multicast is selecting some people to send them the message. Okay, so unicast send to several target hosts, and the source host send several data packets. Multicast, no matter it is sent to several target hosts, the source host only sends one data packet. What does it mean? It means that if it's a unicast architecture, let's say we are playing some games online, right? So unicast means this PC, I'm talking here about endpoints, will talk to that PC separately, and then when it's done, it will talk to that PC separately, and when it's done, we'll go to the third one. This is unicast transmission. But for the multicast, you are selecting those people all together, and instead of talking to each one separately, you are talking to all the people at the same time. So this is the benefit of multicast. One of the protocols of multicast is the IGMB, Internet Group Messaging Protocol. Let's see how you do some configuration on the IGMB on our NBS. Okay, you go for layer 2 multicast and you start selecting IGMB version, if it's version 1 or version 2. Different versions have different terminology. Between the host and the router, between the host and the router, okay, the host and the router that is on the switch, we need to deploy IGMP protocol to complete the normal forwarding of multicast data. So first, you configure the global parameters, the IGMP version, it's version 1. And if there is unknown multicast packet, you're asking the switch to discard or simply drop for unknown multicast packet. Okay, so from layer 2 multicast, select the global settings and start enabling the IGMP, and then after you choose the version, and I do prefer to select drop or discard the unknown multicast packet. This is very important. All right, and then you click save, and then you start to selecting the ports that joining the IGMP. We have talked about DHCP snooping. There is illegal DHCP trying to give you IP address, and it's illegal. Okay. For the IGMP, between the host and the router, again, on the switch, we will deploy, this is the host, and this is the switch, and this is our router connected to the internet. All right, this is host 1, this is host 2, and let's say this is host 3. So after configuring the global settings, you have to configure the ports that belongs to the IGMB. Okay, how you select the ports? If you can see here, the VLAN list, this is VLAN 20, and the router port for this VLAN 20 is port 5 and 6 and 7 and 8. So those ports are the router ports, which is routed ports. For IGMP snooping, you simply turn it on and click save. And after that, you can select to forward multicast data only. As you can see here, IGMP snooping enables layer 2 switches to forward multicast data only to the port of the user that needs it. So the other users will not be affected. What does it mean? Okay, it means that simply this is our NBS. Let's say there is a different BCs here. Okay, different BCs. All right. Let's say this is BC1, BC2, BC3, BC4. If we enable the IGMP snooping, we are enforcing all the users to be shared on the multicast traffic. But for example, we don't want that user one to be joined to that multicast. So we will select only the users we need them to join the IGMP multicast. So we'll select that port and that port and that port. For that port, we are not selecting because user one actually, it's not connecting with us on that multicast traffic. So this is simply the multicast, selecting different users to join multicast session. So what about broadcast? Broadcast is selecting all the connected users all together. This is the difference. So after you selecting or turning on the IGMP snooping, you have to select the interesting ports that will join the multicast traffic. Okay, as you can see here, for VLAN 20, we have selected port 5, port 7, port 6, and port 8. Okay, and then you click OK. So those ports are joining the multicast traffic. Oh, by the way, NBS and ES are GUI friendly devices, graphic user interface. There is no CLI or SSH for such a configuration. So it's friendly GUI configuration. Okay. All right. Next is storm control. What is storm control? From the meaning, it's a storm coming to our switch. All right. It might be affecting the switch itself. So we have to control that storm. Different scenarios regarding the storm controls, by the way, but let's explain how it works. When there are excessive broadcasts, multiple broadcasts, or multicast or unknown unicast data flows in the LANs, the network speed decreases because there is a lot of traffic, and the packet transmission timeout greatly increases. The packet transmission will be increases. This is called LAN storm. which may be caused by topology protocol execution or incorrect network configuration, right? So you might have storm control if you incorrectly configured your network. Users can perform storm control separately for the broadcast and multicast and unknown unicast data flows. When the rate of broadcast or multicast or unknown unicast packet received by the device port exceeds the specified rate, the number of packets allowed per second, or the number of kilobits allowed per second, the device transmits packets only at a specified rate. So you are simply controlling the storm that might be happen because of broadcast, multicast, or unknown unicast. The number of kilobits, as you can see, allowed per second. This is very important. And the number of packets allowed per second. So maybe some devices connected to our switch is sending a lot of unicast or even broadcast or multicast. At this level, there should be here something called storm to the switch itself. So how you control this storm? You have to control this storm to keep your network up. So discarding packets beyond the rate range. You are here saying to the switch, your rate to that storm is, for example, 5 meg. So you are saving the switch performance by limiting those to 5 meg. If it increases more than 5 meg, this is called a storm. Well, until the packet becomes normal, thereby avoiding flooded data from entering the LAN and causing a storm. Well, this is somehow related to rate limit we have just talked about. One of the things that help you to save the control or to control the storm that might happen on your local area network. Okay, for the configuration, you go for the security and storm control, all right? You can as well do patch edit, and you patch editing. For now, we patch editing the port 19 and port 16. So port 19 and port 16, please keep the rate at 1,000 or 10,000, whatever. It's from 16 to 1 gig of broadcast traffic. And as well for the unknown multicast and for the unknown unicast. So you are saving yourself from storm in that way. Well, by the way, storm can do some lag to your network because it's tons of traffic is coming to your switch. It affects the performance and can do some troubles on your network, do some lags, do them speed issue. So storm control is something mandatory to configure on your NBS switch. And as well as we mentioned, it's all GUI configuration, which is very simple. Okay, you just pick up the ports. You want to configure the storm control, and that's it. Okay. All right, we have here selected port 16 and port 19. We have limited the limit of broadcasts and unknown multicasts and unknown unicast. You can set that speed according to your environment. To be honest, set that limit according to your environment. Okay. Okay. Any questions so far? Any questions for the DHCP, for the IGMP? Any questions or any scenarios you have faced on your networks you would like to ask, you would like to share ideas? No, the IGMP is switching things. It's not on the access point itself because you're telling the switch which ports will be subscribed on a multicast session. So it's from the switch perspective. It's not from the endpoint perspective. It's not from endpoint. It's from the switch perspective. So when the data comes from the, well, let's say we play Viva, for example, Viva. And we have server in our network, and that server is connected to the our MBS. Okay. So that server will send the packet to joined PCs of that multicast traffic. Okay, so let's say this is PC1 and PC2. Maybe there is another PCs here, BC3 and BC4. So who will join the multicast? The switch here decide that PC1 and PC2, I will send multicast traffic to those PCs only. PC3 doesn't care about the multicast. PC4 as well doesn't care. All it cares about PC1, PC2 because those ports we have selected on the IGMP configuration. So it's not related to the endpoints. It's related from the switch perspective itself. Okay. All right. The STP. What is the STP? Well, STP simply is blocking backup ports in our local area network to avoid something called layer 2 loops. It's called spanning tree protocol. Okay, it's simply blocking backup ports in our LAN to avoid layer 2 loops. I can see someone here is asking another questions. Well, no, the IGMP is available on the Ethernet ports, and the Storm is available on the Ethernet ports as well. Well, but let me double check for if it's available on the SFP ports or not, because you might connecting some other switches to the SFP ports, which is the uplink ports, and that Storm control might be restricted from the SFP ports. So let me double check for this SFP ports. Hi, Kelvin, can you please record this question? Thank you. All right. So the spanning tree is simply blocking the backup ports to avoid layer 2 loops. Okay, let's take a brief about the spanning tree. Switch portlets blink rapidly at the same frequency. This is a spanning tree. So if you can see the switch, this link on the switch, or this link, or this link, or this lid is blinking very fast. So there is some alert here telling you, hey, note, there is a spanning tree is happening here. There is a loop is happening here. So you have to turn on the spanning tree. Well, if no one knows about the spanning tree, let's take just 5 minutes explaining why we need the spanning tree. Let's say this is switch 1, switch 2, switch 3. They are all connected to each other. And PCA want to send, sorry, let me draw that again. The switch 1, switch 2, switch 3, all connected together. Okay, let's say this is PCA, and this is BCB. This is switch 1, switch 2, switch 3. Okay, let's say BCA wants to send some traffic to PCB. How many ways it could reach to PCB? 2 ways. The first way is 3, 2, 1, and then BCB. The other way is 3, 1, and then BCB, correct? 3, 2, 1 goes to BCB. This is way 1. And the way 2 is 3, 1, and BCB, right? This is the way 2. So it has 2 ways to reach to the destination, which is BCB. In some scenario, if you have multiple BCs here, this wave configuration can do something called loops, going on loops. I want to go from PCA to PCB. Should I go from that way, which is way 1, or should I go from way 2, which is to the switch 3 and to the switch 1? So the STB came to avoid that loop. The STB came to avoid that loop by just telling the switch, if you have already that way to reach to the PCB, I will do just blocking that port. I will block it. Well, this is automatic mechanism. You just enable the STB, and the STB will decide which port in this loop will be blocked. So in that way, if that port is blocked, for PCA, the only way to go to the destination is that way. So in this scenario, we are avoiding the layer 2 loop. What if someone from the technical came and cut that cable? Immediately, in 15 seconds, this port will be from blocked to allow. So this is simply the spanning tree protocol. If you have more than one way to the destination, I will let one way only working and the other way is not working, but I will keep them as a backup. So if the only way is down, the other ways is up, okay? Well, what's the indication of a spanning tree? How do you know there is a loop? How do you discover there is a loop on NBS? The first thing, if you can see the switch port lights blink rapidly, very fast, it's blinking at the same frequency, there is a loop. Switch MAC address table flapping. What does it mean? It means that the switch is receiving that device MAC address from port 1. And it's receiving, let's say this is another switch here. This is trunk port and this is access port. Let's say that PC or maybe some other things here behind that switch receives the same MAC address from that port, which is port 5. So this switch will thinking, I'm receiving the same MAC from port 1 and port 5. How come? So this is called MAC address table flapping. It indicates that there is a loop. Okay, what else? The switch fails to log in due to resource exhaustion. So the loop will consume the processor of the switch, the RAM even of the switch. So if you are trying to go for 192.168.110.x and it doesn't open, so it might be a loop. It consumes the processor, the RAM, all the device is consumed, so there is a loop. So this is the phenomenon of loops. Three things that shows you that there is a loop. Well, what's the drawback? The hazards of the loop. The link congestion. The congestion of the link. The broadcast packets are continuously flooded in the layer 2 network, and all links are flooded with a large number of broadcast packets. So this is what we just explained, right? The flooding of layer 2 networks inside your local area networks. The host system responds slowly. The host network card receives a large number of broadcast packets, and the operating system calls a large number of CPU processors to identify these broadcast packets. So you are consuming the CPU of your host as well. Layer 2 switches are slow to manage. Large number of broadcast packets need to be processed by the central processing unit of the switch, which wasted a lot of CPU resources and cannot respond to normal requests. So actually the switch is busy exploring what's going on on those loops. This is one of the hazards. This is one of the familiar hazards. If the switch is stop responding, it might be a loop. The impact on the CPU of the gateway device. The ARP protocol, the address resolution protocol, requests packet for the gateway IP address are copied and forwarded through the loop, because it's actually a loop. So it's copied from different source to the same destination. That's exactly the flapping, the MAC address flapping. The switch is receiving the same MAC from that port and from that port. So maybe at the other end, there is a loop here. There is a loop here. And that MAC is received from port 1 and it's received from port 2 as well. So definitely there is a loop. Okay. As you can see here, the gateway IP address are copied and forwarded through the loop and are continuously sent to the gateway device, which is our router. The CPU pressure of the gateway device continuously to increase or even crashes. So the loops can extremely decreases your local area network. It affects the CPUs, it affects the RAM, and overall it affects the switch performance. So how you override all those issues? Turning on the spanning tree protocol. Well, by the way, Reyee has something called loop prevention mechanism. Without your IT interruption, you can just simply turn that on, and thanks to the Reyee switch, it will explore where is the loop, and it will immediately turn off the board that the loop happens on it. Okay, this is intelligent loop prevention mechanism by Reyee, right? Okay, so this is the example we have just explained. And again, how you deploy the spanning tree, the solution is deploying the spanning tree. Deploying the spanning tree on the switch logically, it's not physically blocking the switch, the port, it's logically blocking loop interfaces. In the event of physical failure, redundant links can resume normal forwarding, like we have just explained. Okay, all right. So in this example, if this PC wants to go to that PC, well, the only way is that way. Well, and this port is logically blocked. If someone came and cut that connection, this port will sense that there is no other destination to that destination except this way. So spanning tree saves the loops that could happen here if you don't apply the spanning tree protocol. Well, spanning tree protocol is a must, in any local area network. Some devices is enabled by default. Spanning tree is enabled by default. If it's not enabled, you have and you must turn it on. Okay. All right. How you enable the spanning tree? You click on advanced and click on a spanning tree protocol and start turning on the spanning tree protocol. There is some configuration regarding the switches, right? Who will decide? The switches talk to each other. They talk to each other, okay, and ask themselves, who will decide which port is blocked? Who will decide which path is valid and which path is not valid? So simply those parameters is regarding the STP configuration. Okay, the priority, what's the switch will be the higher switch, which decides who is doing what. The maximum age is here, as you can see, in seconds. The recovery time in 30 seconds if the port is blocked. How long it will take to that port to come up again, right? Well, mainly it's 15 seconds, the default for that port to come up again. The hello time, the hello sent between devices, between switches, to know who is the big one, who is the responsible for forwarding and receiving the STP traffic. The forward delay is 15 seconds and the STP mode is STP because there is rapid, another protocol, it's called rapid spanning tree protocol. So from here, you choose the STP mode. Okay, right. That was the MBS, the NBS configurations, right? So far, is there any question before going for the ES? Please feel free if you have any question before going to the ES configuration. Okay, no questions? All right, let's continue. Now the ES. How you log into the ES? Well, for the ES, it's GUI as well as the MBS. You can log in from the GUI from the master device, which is EG, like we have explained in the router session. We have explained that thanks for the song self-organizing network, right? You can log into your network devices if you have multiple network devices and you have EG gateway, gateway, you can manage those devices from the EG itself. So as you can see here, we have ES209GC gigabit, and BOE. This is stand for BOE. It supports power over Ethernet, and it's a gigabit switch. Okay, you can log into that switch from the master device in the Sun network. Okay, you click on switches and you click on manage, and in that way you are managing your switch.
Soy Dagoberto Marmolejo con Osvaldo.
Con Osvaldo.
Ajá.
Ah, sí, adelante, si gusta.
Gracias, gracias.
Okay, Mr. Caesar, it looks like you're turning on the mic. Would you like to ask a question? You are very welcome if you need to ask any question so far. Okay. All right. So as you can see here, EG105GW is the master device for our 209 ES series and MBS 3100 as well. You simply click on manage, and you can manage that switch from the gateway itself. Okay. All right. The option 2, that was the option 1. The option 2 is directly connected your ES switch to your laptop, and for TCP IP configuration on your laptop, you make sure that you are on the subnet of 104477.x/24 is your subnet mask, and you log in the switch from 104477.200. It's directly connected topology. Okay, this is how the switch looks like. It's all GUI, and as we have mentioned, this symbol indicates that it's uplink, and this symbol, as you can see here, indicates it's a PoE port, or the device is connected to that port is BoE capable. Oh, sorry, BoE capable. Okay, this is the host name. You can change it according to your environment. The Reyee cloud status, it is connected, so you can manage the device from your own account on the cloud. The model and the software version, serial number, MAC address, and the current IP address, the subnet mask, the gateway, and the DNS. This is the WAN port of the switch, the uplink. Okay. This is just an overview of the ES switch, the system info tab, the basic settings, and if you need to do some firmware upgrade. Okay, this is monitor info, port statistics, cable diagnostics, and MAC list. We'll see that in a minute. For the basic settings, as you can see here, loop protection, and this is related to spanning tree protocol. This is very important to turn it on, right? Port isolation, like we have explained on our last session, and even the port settings. The port settings is simply turning it on or off, the speed of the port, the duplex mode, is it full duplex, half duplex, or auto negotiate, and the flow control. This is the configuration of each port individually, or you can do patch configuration to different ports in the same time. Okay. All right. Right, we have explained the VLAN on the last session, so please you can refer to the last session recording if you need to revise the VLAN configuration. But from here, the system info, you can do some VLAN configuration. Well, the VLAN is disabled by default, so you have to enable it. The VLAN settings, it's disabled by default, so you have to enable it in order to use the VLAN. Okay. You can add up to 16 VLAN on ES series. 16 VLAN on ES series. 4094 VLAN on NBS. So let's say briefly, ES is a low-end category, right? It's good for CCTV solutions and some small offices, enterprise, medium to small offices. But the NBS is much a little bit higher than ES. The ES limitation is 16 VLAN, right? And you can add the VLAN members from the basic settings here. You can see the VLAN member, and you can add the VLAN number, and then start adding the ports that belongs to those VLANs. Okay. And you just click add, and here you go, it's added. As you can see here, we added port 2 to VLAN 10. Okay. Right. You can even decide if it's access port or trunk port. Access port belong to only one endpoints, and trunk ports is connected mainly between switches. Here, as you can see, you can assign the new VLAN members to ports, which ports belongs to VLAN 10. So port 4 and 5 are belonging to VLAN 10. As you can see here, port 4 and 5 are belonging to VLAN 10, and they are access port. It's not trunk port. And if you need to permit that VLAN on that port, it should be trunk. It should be trunk. Because trunk buses more than one VLAN. So maybe you need to permit some VLAN on that trunk link between switches. Oh, sorry. Maybe you have here on that switch VLAN 5, VLAN 6, VLAN 7, VLAN 8, and on that switch, right, this is trunk port, and this is all access ports. Maybe on that port, you will permit only VLAN 5 and 6 to pass to the next switch, while denying VLAN 7 and 8. VLAN 7, our only job is here. No one here needs VLAN 7 or 8. So this is the permit is dimmed because the port is access. It should be trunk in order to permit or deny some VLAN to passes through this trunk port. Okay. Right. As you can see here, we have added port 5 and 4 to the VLAN 10. Right. And we have talked about port isolation in our last session. So if you need to enable the port isolation from the basic settings as well, click on port isolation, right? Last time I do confirm that downlinks ports cannot forward packets to each other. So avoid applying port isolation to connections between switches. Well, simply, if you do port isolation here, port isolation, maybe this switch is connected to the internet. Of course, there is a gateway here, right? But maybe this switch is connected to the internet. So if you isolate this port from that port, so users here will not going through that switch, and as well will not going through that internet. So avoid applying port isolation between downlinks and uplinks. Okay. And for the configuration, you click on basic settings as well and start enabling the port isolation. okay? And for the speed rate limit, for the configuration of ES speed limit, you can select the port you want to limit the speed and turn the status on and start configuring the rate of that port, right? Well, mainly all the configuration of the ES from this tab, the basic settings. If you want to do some static MAC reservation, if you want to search for a certain MAC address, VLAN configuration, even quality of service, you can configure it from here. So mainly the basic settings is mainly all the features or most of the features on the ES series. All right, for the rate limit or speed rate limit, you go for the basic settings and rate limits and start doing each port configuration according to your requirements. You can select multiple ports, by the way, and select the rate to those multiple ports are equal or the same. All right, and that's it. Some questions here you might find in the exam. What's the default IP address of the Reyee switch? The default is 10.44.77.200. Okay. All right. Does the NBS switch support LASP? LASP? No, it doesn't, because it supports static aggregation, right? It supports static aggregation. Well, for this part, as it's very important, as we have mentioned, if this guy here speaks English, and this switch here speaks Spanish, for example, and we are doing aggregation here, so this one will never understand this one. So they must be agreed on a protocol so each other can negotiate how they're gonna aggregate those ports. So one of the protocols, it's called LASP, Link Aggregation Control Protocol, right? But unfortunately, the NBS doesn't support this protocol. So what you do is just telling the switch, turn this on for aggregation and turn this on for aggregation. So you are statically configuring those ports to be prepared for link aggregation. But if you have LASP, you go for that switch and turn on LASP, and go for that switch and turn on LASP. So as long as they are both working on the same protocol, they will negotiate the speed and duplex and that stuff between those two switches. So this is the difference between static lag and the protocol LASP, right? Again, NBS only supports static aggregation. Right. Does the Reyee device support telnet or console? No. Reyee, which is ES or NBS, they are graphic user interface. Okay, graphic user interface. Right, that's it. Please feel free if you have any question. Anyone have any question on that part? Well, Guillermo, excuse me, let me copy that question. All right. And if you don't mind, please, can you send me your email? Right, my email is that one. If you can just send me an email and I will confirm you if the IGMB and Storm is available on the uplinks, fiber SFP links. Okay. For the purpose of exam experience and sharing, you are welcome to join the WhatsApp group between myself and my colleague Kelvin. right? If you have any question within the exam is not clear, if you have issue registering the exam, you can simply ask us on that WhatsApp group.